Introducing Global Manufacturing's patented Direct Blast Air Blaster. We manufacture two types of blasters: our standard GWE series for applications with ambient temperatures below 130 degrees Fahrenheit, and our G400 series designed for high temperature environments such as cement kilns or steel mills. This video will focus on the blasters for use in temperatures below 130 degrees Fahrenheit. What makes Global Air Blasters different? They are the only blasters that do not use mechanical springs, and unlike competitors' designs, they are designed to be completely airtight. With no springs to wear out and fail, and absolutely no air leakage, your air blaster will be ready always when you need it. Why are Global Air Blasters so powerful? Our unique valve design ensures that the air blast takes only one 90-degree turn. Some competitors' models route the air through a series of corners which total 270 degrees in bends. This winding path slows down the discharge of air and greatly reduces the blast force. Our direct blast design is why Global's air blasters have the most forceful blast of air in the industry.
Why are Global Air Blasters so competitively priced? We designed our blasters to have the fewest possible number of parts. And while simplicity may sound easy, it's actually the most difficult part of product design. We don't add any features or gizmos that raise the cost unnecessarily or do not contribute to the efficiency of the product. What is an air blaster? An air blaster is an ASME certified pressure vessel that stores compressed air. By a combination of electrical and mechanical actions, the entire volume of compressed air is released instantaneously, providing a powerful, high-energy blast that is used to dislodge even the most difficult bulk materials. Now, a brief description on how the air blaster works. The pressure vessel is pressurized through a three-way normally open solenoid valve. The air supply passes through the quick exhaust valve, down the copper line, and into the valve body. Pressure forcing the O-ring on the nose of the piston completely seals the valve against air leakage. Once the piston is seated, a one-way check valve in the valve cap is forced open and allows the air to fill the tank. Once the pressure vessel is filled, the blaster is ready to be fired. To discharge or fire the air blaster, the three-way solenoid valve is energized, shutting off the air supply and releasing the air holding the quick exhaust valve piston closed. The pressure in the copper fill line and valve body blows the quick exhaust valve piston back, exposing vents in the quick exhaust valve body. This immediately reduces the pressure behind the piston, allowing the pressure in the tank to force the piston back very quickly. As the piston opens, windows in the valve body are exposed and the pressurized air in the tank immediately escapes through the discharge pipe. Depending on the tank size, this whole process takes as little as 90 milliseconds. Less than half the time it takes you to blink your eyes. For example, at 100 psi, our smallest air blaster discharges the entire 11.7 cubic feet of compressed air in just 0.09 seconds, while our largest air blaster discharges 155 cubic feet of air in 0.46 seconds. That is less than half a second. With air velocities in excess of 1,000 feet per second, which is 680 miles per hour, our largest air blaster creates approximately 4,000 pounds of force.
Let us look at some of the key components of the air blaster. The pistons for standard applications are made of a stable corrosion-resistant polymer which requires no lubrication. Without having to buy, fill, and maintain inline lubricators, you save time and money and avoid introducing residual lubricants into the environment. The key feature of the Global design is the patented quick exhaust valve system, or air spring, which provides our air blasters with superior performance advantages over designs that use a mechanical spring. To understand the value of the air spring, let's review what happens when an air blaster fires. The more quickly the piston retracts past the exhaust ports in the valve body, the more quickly the valve opens and the more forceful the blast. This accelerated piston movement presents a problem, so it must be rapidly slowed down and brought to a stop prior to impact. If the piston impacts the valve cap, At the speed it travels, it will damage both the piston and the valve cap. Our air spring solves this problem by trapping air between the piston and the valve cap. This cushion of air halts the travel of the piston before it ever contacts the cap. Once stopped in the retracted position, it is preferable for the piston to be returned to the valve seat in a controlled manner. This controlled close is also achieved by our patented air spring design. The greatest advantage of our air spring over a mechanical spring is its reliability. Because a mechanical spring works by resisting compression, they all eventually fatigue and break. Our testing revealed that the spring is compressed and released many times during each firing because the piston oscillates or flutters with the changes in the dynamic air pressure during the blast discharge. We measured 28 high amplitude cycles and 55 low amplitude cycles during the 0.14 seconds it took the mechanical spring to close the piston. Considering that data, a mechanical spring's 1 million cycle duty rating is exceeded in as few as 12,000 firings. What's more, when a spring fails, it causes significant damage to the piston cap and valve body. That's why we designed the mechanical spring out of the Global Air Blaster. The Global valve body and seat are triple-coated chrome plated. This unique layering of copper, nickel, and chromium provides excellent chemical resistance as well as superior protection against abrasion and wear. The valve cap is not exposed to the environment. It is one piece with an O-ring check valve. The cap is held in the valve body with a simple retaining ring. No screws, no other fasteners. The copper fill line is held in the cap by the rigidity of the line itself and sealed in the cap by an O-ring. Why did we choose O-rings for our air blaster? O-rings are very reliable and significantly reduce any metal-to-metal contact. By the way, you will not find aircraft, spacecraft, artillery equipment, or even motor vehicles without O-rings. During initial product development, we inspected air blasters that had 12 months of severe environment exposure, and the O-rings were nearly pristine.
We hope we've given you an understanding of how our air blasters work and the components we designed for them. Our blasters are designed for maintenance-free operation. Try them and you'll see what many satisfied users already know. Global air blasters are the best in the business. We stand behind our products always. If you have any problems with your air blaster, we will be happy to make it right. No hassles. In the U.S. and Canada, please call 800-551-3569. From all other locations, dial area code 501-374-7416 to get help with your air blaster application. When you call, a real person will promptly handle your request. We are happy to discuss possible solutions at no cost to you.